All right, mathematicians, let's get started with section 1.3 using the midpoint formula. Our objectives are that legends will be able to find segment lengths using midpoints and segment bisectors, partition a segment on a number line, and find the midpoint of a segment in a coordinate plane. Key point number 1. The midpoint of a segment is the point that divides the segment into two congruent segments. Let's take figure here of segment AB. M appears to be in the middle, but we can only conclude that when we have matching number of tick marks on each side of M, which does mean congruence. So if you see a matching number, we can conclude that M is the midpoint of our segment. So segment AM is congruent to segment MB, and the length from A to M is equal to the length from M to B. So that takes us to a segment bisector. It's a point, ray, line segment, or plane that intersects the segment at its midpoint. So a midpoint or a segment bisector bisects a segment. Well, the word bisect means to cut into two equal parts. So let's take that same segment AB and now bisect it with a line. So we can say that line CD is a segment bisector of segment AB. So segment AM is congruent to segment MB, and the length from A to M is equal to the length from M to B. All right, so let's take a look at examples of all these different figures that can bisect any segment. So here we have segment YZ bisecting segment AC, and we have matching tick marks. The point of intersection is B. So YZ is a segment bisector of AC. We can also have lines that bisect. So here we have line L bisecting segment AC. We can have a ray, so ray MN is bisecting segment AC. And we can have planes bisecting segments. And so we have plane P is a segment bisector of segment AC, and the point of intersection is B for all of these figures. All right, so in the skateboard design here, we have segment VW bisecting segment XY at point T. So we have a segment that's a segment bisector, and then we have XT is a length of 39.9. So we want to figure out and find the length from X to Y. So we know that each of these parts have equal lengths. So we can set up our segment addition postulate that says XY, the whole length from one end to the other of the skateboard, equals the parts. So XT plus TY. So then we substitute the 39.9 for each of the segments and add that together, and we get 79.8. So the length of segment XY is 79.8 centimeters. Example 2, we have point M is the midpoint of segment VW. Find the length from V to M. All right, so we'll first set up an equation that illustrates our equal parts. So we have M at the midpoint. So that means 4x minus 1 equals 3x plus 3 by substitution. So we use our algebra skills, combine like terms, move our x's to one side, so x equals 4. Then we substitute, and so x substitutes with 4, and then order of operations means that the length from V to M is 15 units. Alright, so you pause the video here and try this problem on your own. You're identifying the segment bisector of RS. So you're identifying what type of figure bisects segment RS. Is it a line, a ray, a plane, or a segment? Then find the length from R to S. So pause here and take a moment to answer both parts, then unpause to check your work. Alright, so the segment bisector is a line N, and the length from R to S is 66 units. So if these answers do not match your answers, just pause the video here and compare your work to mine and see if you can identify the error. And then if you still can't identify the error, then bring in clarifying questions to class. Alright, key point number 2 is to find the midpoint on a number line. And we do this by determining the average of the 2 points. This is a single number line, so just x's. So you get an x1 coordinate for your endpoints and an x2 for the other endpoint. And we're trying to find the middle point. So we would add the two endpoint coordinates together and divide by 2. So let's take a look at example 4. So the endpoints of CD are at -3 and 5. So you can definitely sketch out a number line. A picture is always helpful. And you're going to find the coordinate of the midpoint M of this segment CD. So we need to add the -3 and the 5 together and then divide by 2. So when you do that, you get 1. So the midpoint coordinate M is 1. All right, next we have key point number 3, partitioning a segment on a number line. So partitioning for a segment JK with endpoints at coordinates x1 and x2, the point P with coordinate at a times x1 plus b times x2, all divided by a plus b, will partition the segment in the ratio of b to a. So this is a situation where we're finding out a P that's not at the midpoint. So we're not looking for a midpoint when we partition a segment for some ratio B to A. So note the arrangement of our numbers. One thing that might be helpful to know where all these numbers are going to get plugged in. We know that x1 comes before x2 when you read your number line from left to right. Just like A in the alphabet comes before B in the alphabet. Well, A part of the ratio, which is your second value, it's a B to A ratio. Your A part of the ratio is going to get multiplied by x1. So A comes before B, just like x1 comes before x2. And in the denominator, you're just going to add A and B together. So the order in which you add doesn't matter. So if you can kind of remember this way of setting up your equation, partitioning situations will go a little bit easier. Hopefully. Let's see. So let's take a look at this first example pertaining to the partitioning of a segment. So example 5, and again, anytime you have no picture, always draw a picture to help you illustrate your situation. So the endpoints of segment AB are at 2 and 8. Find the coordinate of point P that partitions the segment in the ratio of 2 to 1. So again, assign numbers for A, B, x1, and x2. So here we have x1, x2, this is B, and this is A. So we know that A is going to get multiplied to x1, so 2 times 1, plus then 2 times 8, and then all divided by 2 plus 1, which is 3. So let's see this in action. So here we have 1 times 2 plus 2 times 8, all divided by 1 plus 2. So use your order of operations, you get 18 divided by 3, which equals 6. So our point P will land at 6 and have the ratio of 2 to 1. And there's a picture to go with the situation. Alright, so let's monitor your progress for midpoint and partitioning. So try these 3. Number 5 and 6 have to do with partitioning a segment, and number 7 has to do with finding a midpoint. I included our formulas here just for review. Also, you can look at your notes for examples, and pause the video here, try these 3 on your own, and then unpause the video to reveal the answers and see how you did. Alright, for number 5, you should have gotten that the coordinates of the point P that partitions segment EF in the ratio of 4 to 1 is 5. So pause the video here if you did not get 5 to compare your your work to my work and see if you can identify your error. For number 6, the coordinate of the point P that partitions segment LM in the ratio of 1 to 3 is -4. Again, check your work compared to mine if you made an error. And finally, number 7, the coordinate of the midpoint M is of segment QR is -2. So if you need additional clarification, please bring in clarifying questions to class. All right, next we have key point number 4, where we go into a coordinate plane to find a midpoint. Now the coordinates of the midpoint of a segment are the averages of the x-coordinates and of the y-coordinates of the endpoints. So let's say we have point A at x1, y1, as you can see here in this picture. And then you have B at x2, y2. So the other end of the segment is at x2, y2. So segment AB are points in the coordinate plane. Then the midpoint M of segment AB has these coordinates. So if we want to find the midpoint coordinates, x and y coordinates of the midpoint, we add we would add the x's, and I just see that we have a mistake here, so let me fix this real quick. You would add the x coordinates 1 and 2 and then divide by 2 to get the midpoint x coordinate. And then you would, in a separate fraction, add the y coordinates, y1 plus y2 divided by 2. Well, it's correct over here in this picture. So the x's divided by 2 and then the sum of the y's divided by 2. 5a, the end points segment RS are at R1, -3 and S4, 2. Find the coordinates of the midpoint M, check your answer. Go ahead and take a moment to pause here and plot out your points. All right, as you can see, segments endpoints R and S are plotted, so check your plots compared to mine. And let's set up our equations. So we know that we're going to be adding the x's, so 1 plus 4 divided by 2, and then adding the y coordinates of the endpoint, so -3 plus 2, all divided by 2. And that simplifies to -5/2, comma, -1/2. So the midpoint is at 5/2, -1/2. Let's take a look at our next example, B. The midpoint segment JKR M21, one endpoint being at J1, 4. So first let's plot, and we want to find the coordinates of the other endpoint. So once you plot your coordinates, so pause the video here and plot real quick. So it should look something like this. Of course, you may or may not be able to figure out where this is by graphing, which you kind of can using slope. But if you're going to use the formula, you want to first set up your equation to find x. So step 1 would be set up your x coordinates. So 1 plus x divided by 2 equals 2. Now we know one endpoint x coordinate is 1. We don't know the other endpoint, so that's why it stays x. And we know the midpoint x coordinate, which is 2, so that's why all of the fraction is equal to 2. So we need to multiply both sides by 2. And that takes care of the 2's on the left side. So now you just have 1 plus x equals 4, subtract the 1, so x equals 3. Now let's find the y, that's our second step. So we set up our equation. Again, you've got your y coordinates, so 4 plus y, which is unknown, the other endpoint's y coordinates unknown, equals, divided by 2 equals 1. So again, we're going to multiply both sides by 2. So the 2's will cancel out, or divide to be 1. And that leaves you with 4 plus y equals 2. And then subtract your 4 on both sides, so y equals -2. So your end point K is at 3, -2. And that's all for lesson 1.3. Bring in all your notes and hard work, and we'll practice in class.